Alright, so one topic I found interesting and surprising in this class was the result of the Monty Hall problem. But before I explain that, I just want to review a core concept, the law of total probability, because it'll make the explanation a little easier. So, law of total probability states that if we have a sample space omega, and we partition it between subsets b sub I through b sub n, that must fill all of omega, then we have a sample space A inside, well, the probability of A equals the summation of the probability of A happening in B sub I times the probability of B sub I happening. And that is added through b sub I all the way to b sub n, so in this case 1 through 5. So we're just looking at the probability of A given b sub I happens, and then we multiply it by the probability that b sub I actually happens in the first place. So basically we have these, you can visualize it by just these little shapes being added up, and when they're all added up we get A. So what we're doing is we have a complicated problem and we split it up into 5 easier problems to solve. We add them up and that gives us the answer to our complex problem. So this is what we're going to do with the Monty Hall problem. So if you're not familiar, it's a game show where there's 3 doors. There's 2 goats and there's 1 car behind the door randomly. We don't know which is which. So at first we pick a door, and the host comes in and reveals a door with a goat, and offers you to switch. So the question is it statistically probable to switch, stay, or just it doesn't matter what you do? Well, it turns out that it is probable to switch, but let's prove why. So let's say we have a sample space like omega, and we partition it with 2 cases. Either b sub 1, you initially picked a goat, which is 2/3 of the time, and b sub 2, which you picked a car 1/3 of the time. And there's 2 things you can do: switch or stay. So let's just look at the law of total probability. We have 2 b's, so b sub I through b sub n is just b sub 1 all the way to b sub 2, just 2 cases. And in the first case where we stay and initially picked a goat, if we initially picked a goat and stayed, then our odds would just be 0 times 2/3, because 2/3 of the time we picked a goat and lost, plus 1 times 1/3, so 1/3 in total. But if we switch and we initially picked a goat, then 100% of the time we will win 2/3 of the time, plus 1/3 of the time we will just lose. So it's 2/3 of the time we will actually win. Hopefully that makes sense, but there is another game show, Deal or No Deal, where you have, I think, 30 cases and you pick one by one by one. Just each has different amounts of money, and if you make it to the very end, you have 2 cases, and you can either switch or stay. So in this case, it doesn't matter if you switch or stay. The odds are actually the same because there is no outside information given to you. If in the middle of the show they were they revealed a case that had a low amount of money or a high amount of money, and then offered you to switch to another case, it would be favorable or unfavorable. But because no information was given to you, your odds are completely the same. So deal or no deal, switching actually doesn't matter. But in this case, you should always switch because it's going to boost your odds by 1/3.